And letter D. So D would like to know position at t equals 2. So if we want to know position, we really want to know the value, the function value of s of t. That's position, right? So if you're given a derivative, but you want to find the actual value of the function that came before the derivative, you just use the integral. So the integral from 0 to 2 of v of t should give us, if you do all this accelerating, it should tell us what your position is at the end. Except we need to do one more thing. We need to see if we started somewhere. And in fact, we did start somewhere. We started at y equals -1. They actually told us that in the introduction. So -1. So s of 2 is going to equal figuring out how far it's gone from velocity, and then accounting for the -1 it started with. So you can literally put that in your calculator, and when you do, remember we can just use y1, that you'll get -1.360, and you don't have to use units because they didn't give us any units. And they wanted to know if it was moving toward or away from the origin, and this is a little tricky. So its position is here. Remember we're on y-axis now, so its position is -1.3. Oh, I'm sorry, at 2. Its position is -1.360. So we're negative. And then velocity when t equals 2, we already found that in letter B. We found velocity was negative. So if you're already down here and your velocity is negative, that means you're moving away from the origin. Then you're still moving away from the origin. So you have a negative value and you're moving away from the origin. We're going to say moving away. Because velocity is negative. Notice I'm writing v of 2 is negative. And s of 2 is negative. All that means is v of 2 means that you're moving, or if v is negative, it means that you're moving in a downward direction or maybe a leftward direction. But it said y-axis. So we're moving in a downward direction. And since we were already below the origin, we're simply moving further away. That's it.